And Sarko suggested that I prepare a quick
Juan, sorry, just wait a second because I think we want to record this, so I'm not sure what.
I just started it. We're good.
Oh, sorry.
Yeah. So basically, Sarko, I mean, we were discussing, and there was a suggestion that I prepare a quick presentation so everyone is kind of aligned on where we are with respect to Tendermint and KMS and how things work and what are the related ADRs and everything. So this is a quick presentation, and later there is a bit of kind of space to discuss like how we can improve testing also with respect to this and other components. So basically, like the relation between Tendermint and KMS, it's quite simple. There are like two independent repos, the Tendermint node that we all work with, and also there is a KMS repo that it's coded in Rust. And KMS referencing something called a signatory that has providers for different hardware security modules like Ledger or UB, or even like some soft signers like I don't know, ED25519 or different implementations for this. So there are a few ADRs that talk about this, but they are not really specific, or they are not like really covering everything. We had the discussion of the changes last week, and the question was, do we have anything like an ADR for what it was before or after we are planning to do? And the answer is kind of no. The purpose of the KMS is that when a Tendermint node needs to sign some vote or proposal, this is sent to the KMS. The KMS will provide a signature and send the answer back, and then the Tendermint node will relay that. The idea is that this provides kind of a more secure way of keeping the keys, because the key is kept typically in an HSM. That's very secure already, but we also have a kind of like strange relation between the KMS and the Tendermint node, because even though Tendermint will make a request to the KMS is designed to dial in to a node. I will go into detail in the next slides. Now, what do we have in ADRs? And I put something there in orange. Sorry for so much information in the slides, but I think I prepare this more like a kind of a document so you can keep as a reference, or we can later click and see what's going on in each of the issues. So one of the ADRs is ADR 8 that is in draft state. And basically what it says is that we will have different implementations for kind of the private validators, how we validate in the node. One is the file PV, which is basically a local file that stays in the same host as the node and keeps the key there, which is fairly unsafe. And later we have like two ways of connecting to an external validator, which in this case is the KMS, one via TCP and the other one is using IPC like Unix sockets. There is a discussion in the ADR about something called Ledger PV, but in practice this has resulted in a bigger KMS system. That is what we are using today. So the ADR is kind of getting old. Maybe, I don't know what is the typical process. We review them or we like supersede them with like another ADR. But this is not actually a description of what we have today. By the way, if you want, please, I prefer if this gets interactive, so stop me anytime.
So Juan, I think this used to be, this refers to kind of how this was like a proposal months back for a refactor. Like this package has been refactored a few times. Yeah. So I think this did describe roughly the state of things once upon a time, but it's evolved since then, either according to ADR 24 or just other changes in the repo.
Correct. Yeah. Yeah. I mean, what I noticed is that there is no really up-to-date ADR, but still, this is something that maybe what we discussed with Sarko and Ismail last week is that maybe this quick discussion today and the refactoring that I did and is already in progress can result in a new ADR where we kind of finalize everything and make it final.
That's great.
So
yeah, probably we want to have like up-to-date specification and ADR which reflect decision made at one point in time. So ADR is more like historical set of records, but so there shouldn't be a like concept of up-to-date ADR. It's more like then there should be a specification which is hopefully kept up to date.
Right. Yeah. Yeah. That's what I said. That I didn't know, but I assume that maybe there is a kind of ADR that supersedes other ADRs, and later is in spec. And yeah, yeah. I mean, these are kind of like in a bit independent ADRs that are related to these modules. But so ADR 24 only talks about like how we kind of exchange the messages and how we serialize the messages. At like a certain point in time, these were like JSON strings, and the decision of that ADR was to start using Amino and to organize this in a request-response fashion. So, and also to kind of discuss about like having some error types, and there was some discussion of, for example, having a sign both request and a sign both reply. And that's where the ADI finishes. So to sum up, the two ADRs that we have is one that says we have a local validator or an external validator that can talk via TCP/IP or Unix sockets, and the other one is let's use Amino for the exchanges and let's have a request-response kind of mechanism between the node and the external validator. That's ADRs that we have today. So then we have something that is already working and is being used by the community, and there are a lot of like related issues that are the outcome of like the actual code, but they are not like a result of the ADRs or any kind of specification. So one thing is there was in the implementation heartbeats were introduced. Heartbeats are typically kind of useful or required because TCP/IP in certain cases is very hard to know if the remote endpoint has kind of died, and if it doesn't send like a, I can go technical later, but if it doesn't send a kind of like signal that the connection was closed, then you might not know what happened, and you cannot deal with that, or you might need to recognize that the endpoint is broken because of a timeout. So the idea is to trigger that timeout earlier by having this kind of heartbeat, but there were some issues. And one of the things is that in the same channel that we are like sending these request response messages between the Tendermint node and the KMS, we were also sending the heartbeats, but the way the messages were processed were not like kind of multiplexing or demultiplexing, and there were no kind of threading synchronization. So there were like issues with this. But the moment is like open issues is we need to improve the implementation. If the signatures that like the signature request fails in the same channel, then you might have like heartbeats that are affected. In some cases, we have like this issue, this one that says consumes out of order message if previous sign request time out. And there is also kind of a discussion on like mutexes. And the main issue is that we are kind of like have two different kind of threads that are active, are working in the same channel, and this is kind of resulting in problems. So then there are other open issues and improvement proposals that are not related to the heartbeat that have also been going on in the KMS. Like we don't have in the handshake between the node and the version and the KMS, there is no versioning. So sometimes you don't know which version of the node or the KMS you are like working with. So that can result like in an integration issues. We have also kind of like missing chain IDs. When you want to start the node, there is a kind of a sequence of steps that you need to take, because if one is down and the other one starts too early, they don't connect. Also, there is some manual confirmation in the HSM that you need to make. But if that fails and you are not fast enough, then you might have a timeout in the node and the node shuts down. So there are several issues there. Obviously, I'm going fast because I think it's good to give you like a big overview, and later we can go back and review all these details. But this is kind of, we have a kind of bunch of issues that we want to address. And on the other side, there are some open issues that have been discussed over time and kind of revisited many times. That is that we don't have a proper full integration test between the KMS and the Tendermint node. And at some point in time, the harness had to be kind of disabled and later enabled. And in some cases, there is no kind of clean overview of the issues that affect both. So at some point, there is a risk that they can go like misaligned, and people might be using the wrong KMS for the wrong Tendermint version. And we don't have a kind of proper way of testing that either. So the kind of as a summary of this, the problem is we have something that is in a way critical for the network to work, but also we don't have like a kind of appropriate testing strategy for that. And we need to make a lot of changes there. I mean, this is going to be something that will evolve like over time, and we will kind of need some improvements there. So testing that makes sense in order to ensure that the network always works. So that's kind of like a summary of where we are today. So to kind of give you a kind of more technical detail on how it works, basically, this is a bit after the refactoring. Today we have a node, which in the case of Cosmos is for example, Gaia D. And we have a KMS that is connected to some HSM like a UE or a ledger. The interesting thing, and what complicates a bit more the testing and the code, and the reason I have like kind of refactoring a bit things is because there were like kind of the concerns were like kind of unclear of like what was the kind of reason for each of the classes. Is that the KMS dials in to the Tendermint node, but once the connection is established, there is a kind of inverted client-server relation between the node and the KMS. So the node has a state machine. The state machine requires a vote. That vote is sent to the signer client. And now the signer client requires a connection to the KMS, but that might not be there because it needs to wait for the KMS to dial in. So it needs to open a port and wait for the other one to appear. In the meantime, the state machine might be blocked, waiting, and this is something we discuss if we block or not, but it might need to wait until the endpoint and the connection is established. And once that happens, starts to kind of, the listener will connect to the KMS on the dialer endpoint. That will result in a call to the signer service, and then the signature will come back. Now, in some cases, you might have a drop in the connection, and then the problem is that the state machine, which is like kind of triggering the connections, it needs to wait until another connection comes in. So we have a kind of like a mix of a client server from one side, like kind of dialer listening direction, and another kind of flow, which is the state machine trying to reach the HSM. And that complicates things a bit, but that only happens in the TCP implementation, and the Unix kind of local validator do not have this. And the code at that point in time, it was like kind of mixing all these. So transport and signing were all mixed up. And the first thing I tried to do is to separate these. So we separate completely the part where the transport is established to the part where we need the signer to connect to the service, the signer client to connect to the signer service.
Right.
The other thing is heartbeats.
Sorry, Juan. I just want to clarify a few things.
Yep.
So, are you saying that this like inversion thing we do, where first the KMS dials Tendermint, so from initiation, KMS feels like the client, but then from an actual request handling, Tendermint is the client because it's sending the requests.
Correct.
Is this? Have you seen this paradigm before? Like, do we have a name for it? Any precedent for it? I mean, the justification we had was, well, the requests are coming from Tendermint, but we don't want to open ports on the KMS. So we let the KMS dial, set up the connection, and then invert the flow. And like, so for this use case, it makes sense, but it causes everyone a little bit of cognitive overhead to think through it. And I don't know if there's anything we can point to be like, oh, it's like this, so that there's precedent or something. Have you seen anything, or anyone else maybe?
I've seen it called a hanging connection in Google Cloud.
A hanging connection?
A hanging connection, yeah. Where you have, I think they use it for configuration. Like if you have like a consensus engine, like etcd or whatever, and you want to coordinate calls to things like, or a change to a key like the primary SQL server, like the master or something like that, like something that will change. From the command line, you could use this thing to set up like a hanging connection that will only get resolved when the key changes. So it says like, I'm going to set a bash script that is going to initiate a reconfiguration of the MySQL master. And then my bash script is going to I'm going to start it up and it's just going to hang. And then at some point, it's going to get resolved. Is that similar to this?
It's similar in the sense that you're opening a connection from your client machine and then waiting for information from the remote.
Yes, but this is the KMS servers open the connection Tendermint and then wait for the other way around.
And then waits for requests. Yeah.
Yeah. So the KMS opens up a hanging connection to Gaia.
Yeah.
And then when Gaia wants something signed, it resolves.
Right. But the connection, it doesn't close the connection. It actually, it's persistent and.
Okay. Yeah.
That's response.
Yeah. So it's different.
Yeah. So calling it hanging might give the wrong connotation.
I think something similar. I mean, if you run a Tor hidden service, I think it also you don't need a port open on the Tor to inside to the Tor hidden service, but only to the outside, because it can like connect to some I think called rendezvous point or something, and then it can serve requests actually. So that's the only thing I know, which is like kind of similar, but like in detail, it's very different.
Interesting.
I mean, not as a name, but a very similar situation is when you have like a VPN and some service running on top of the VPN. You actually do not care. I mean, if let's say you have a router that has a VPN kind of endpoints, and then you have some network running on top, you actually do not care like how the transport is established. You just want the transport to be there, and the VPN, it's supposed to keep that connection stable.
Right.
But I mean, right now, after the changes, this is kind of a bit irrelevant in the sense that there is one kind of group of classes that are about like establishing the connection and keeping the connection alive. And there is another set of classes that are about signing.
Right.
And the reason that this is kind of separated this way is because the establishing the connection only is strange in this way when you're using TCP, but in the case of Unisockets and local validators, it's not. So there was no need of like kind of mixing these two concepts, and now they're completely independent. One is about connecting, the other one is about, you just call ensure connection, and when you call ensure connection, it will kind of block or say, no, the connection is not there, and then you can do whatever you want.
I thought we fixed that so that in both cases, the KMS dials the node. But you're saying if it's a Unix connection, the Tendermint will dial the KMS?
No, but there is no dialing in a way. I mean, if you're like using a local, or if you're using a Unix, in a Unix socket, there is no actual listener there. Just like, you just need both to open the socket and they can start talking. So there is no actual concept of like listening there. I mean, now this is kind of, I think it's not an issue. I mean, in the new design, in a way, you just need to say ensure connection, and once ensure connection kind of comes back, you can start like calling the service, and that's it. Kind of in the background, ensure connection, depending on what kind of transport you're using, it will like open a listener and wait, or it will just like open, or it will just like, in the case of the private validator, doesn't care.
So it's like Tendermint start with a KMS configure. I guess this is some sort of configuration parameter, whether you use KMS or not. Like, it seems that this is sort of hard dependency. Like, you should not even, you should not start effectively node if you are not able to establish connection with KMS within some bounded time. So
today, if there is no connection with the KMS, the node doesn't start. If you have like a configuration setting that says this requires a KMS, we just listen, and if the KMS never comes for a certain time, it will time out, and the node will stop.
Okay.
And that's something that actually there have been proposals, and I will talk about that later, that it should still anyway start and do nothing and keep waiting. Because maybe I tell about that right now, but the concept is that in this way you could have like several Tendermint nodes in standby in different places, and with a single KMS you could like dial in and start any of the standby nodes, and if you want to switch to another one, you could like immediately drop the KMS connection and connect to the other one. So in a way, the KMS can drive several Tendermint validator nodes that are in a standby. Does it make sense?
The use case of that is some kind of high availability of the validator, or what?
Yeah, that there has been a bit of discussion about that in GitHub. Tony wanted to kind of like add that functionality to have a kind of high availability, or even kind of suddenly migrating, because you think that, I know, you want to kind of confuse some attacker, like every now and then migrating which is the validator node.
Interesting. So there, I mean, there's a few, there are some other proposals for being able to do that. Like, we wait for the genesis time when we start Tendermint before starting anything. And I think there are some architectural challenges in the current code base to being able to start things up without starting other things that are then going to start later. So it might take a bit of disentangling to make that work, but it's an interesting idea for sure.
Sure. I mean, I think the kind of concept I'm trying to, in a way, convey is that we have like multiple cases and multiple proposals here and there, that if we make the change, it will probably look exactly like this PR, that it gets stuck for a certain time because we cannot really test it. That's kind of the main idea behind all this, that testing all these changes is kind of hard at the moment, and it's a critical area too. So we probably want to kind of like address that.
Yeah.
So then we have Heartbeats. The idea is that we could do a kind of multiplexing and kind of separating the packages and manage them, like doing something similar to packet switching or whatever, but it was like too complicated. And some weeks ago we were discussing with Ethan and Ismail, and the decision was there isn't much going on in that channel, so why don't we just remove the Heartbeats? Don't go fancy, just remove them. But that means that we need to kind of handle timeouts in a fancier way, because if a signer client sends a message to a signer service and the connection drops, but we don't know it has dropped because, I know, suddenly the network cable was unplugged, which is a typical case where TCP will not tell you that the connection has been dropped. Then we need to handle the timeout, and then the signer needs to somehow say, okay, this timeout, the listening endpoint needs to drop whoever is connected and try to listen for another KMS that will like dial in. In the meantime, it needs to hold on the client there for a while. And okay, all these things had to be done. So that's part of the removed heartbeats, which is not just like deleting, and then some extending error types and reworking on the unit test and the current test heartbeats. So that's what the PR entailed. And now we went through kind of the review of the PR changes, and basically maybe we can go back to this, but this is basically what was done, and it resulted in some spin-off issues like get pub key at the moment cannot propagate any error. It just says this is the pub key or returns nil. But now I go back once. When the state machine or the signer client wants the pub key, actually has to go through all this process to get the pub key from the HSM. And there could be tons of different errors or situations. And right now, the only thing that signer client gets is nil, so you don't see what happens.
It should only have to do this once, right? Like only on startup should it have to get the pub key, and then it can memoize it for the rest of the duration.
Yes. I'm not sure if in the kind of fancier way where the Tendermint node is in a standby, it might happen that I know we switch HSMs or things like that. But ideally, it should only happen once when the node gets started. Yeah. But still, there was this thing. I mean, we discussed this with in the PR with Anton, and Anton said, "Yeah, let's put an error message in get pub key," but that was like making the PR a lot bigger because get pub key is part of an interface that is like everywhere. So we just opened another issue for that, and there was a bit of repeated code here and there, and that also was like kind of growing the PR a bit too much. So there are a few kind of like spin-off issues that we might want to address later. So now this is basically what I just told. I mean, there are also a lot of improvement proposals, like how about we get like several nodes, and then the KMS can dial into one or the other and kind of do some kind of load balancing or kind of killing one node, and kind of fancy things that are there. But the problem is that we don't really have an easy way of testing that all this works. We know that the KMS Tendermint node relation works well because it's being used, but we don't have like much more kind of information than that in practice. And then there are other things that people have been complaining about. Like right now, the way this works is you start the node and the KMS. The KMS receives the next vote. The next vote kind of has the round and all the information there. That goes into the HSM. The HSM shows you which is the round that is about to sign. And then you need manual confirmation to say, okay, this is from now on, I want to use the HSM. You click OK. And now the HSM only signs in a monotonically increasing way. So you cannot double sign. There's no way you can double sign with that HSM. But people need to be at the data center and take there. And some people have been complaining about that. So there have been other kind of more changes that we might want to test. Like, for example, you have another offline HSM where the HSM that is at the data center sends you something that you can sign with your offline HSM to activate the one at the data center remotely. So then people do not need to be at the data center. And there are kind of things like this that we might want to explore. I think in general, Tendermint KMS, it's another of the things that are never finished. There will be kind of changes over time and improvements and things like that. So now the question, and obviously something that it's about like how we deal with this, is why is this issue? I mean, I work on this because when I did the ledger integration for the KMS, there were a few cases that were not working well, and we found out that we have to make some fixes here and there, and then that resulted in the heartbeat, and then I did that, and the PR has been like kind of getting better over reviews, and reviews. But we could never merge it because me and Ismael, we have been like working on this, but there is no actual way of testing this apart from kind of doing that manually, like kind of unplugging a cable or putting a breakpoint to simulate that something is failing. There is something really nice that Thane made for the KMS. That is the test harness, and I have updated that. But still, the problem with that is that it's not part of CI. So we have worked with Thane and Ismael trying to see how we can make that part of the CI. So wherever we change Tendermint or KMS, we have certain kind of safety net to ensure that the PR is not breaking everything. So, I mean, at some point, maybe Ismael and me, we have to man up and say, yeah, click merge. But up to now, we have not done that. How we can solve this in a more formal way, I think one, and this is not just my idea, it's something we have been discussing for some time, like different people, is that we should have some kind of CI for Tendermint KMS in the PRs, and maybe to have, and this is more a kind of broader, like some kind of integration testing that puts together several repos like the KMS and the Tendermint nodes, or maybe to have a test net where you have some kind of like staging releases or canary releases where we can like see that things are working in the testnet. And there is another thing that is like tooling, and I think in this way we are addressing something that we have like a discussion with Greg and also Anka, and maybe this is more like eat your own dog food. Like I suffer this also myself. So the idea is that how we can improve the way we write this kind of code. Because today it's kind of hard to test, or at least I found this myself. Maybe I'm not like using, maybe someone has some other tools, but up to now I have not found that. How we can like, I don't know, someone tells me there is a problem between Tendermint and the KMS or between two peers in the peer-to-peer network, and I find some bug report, and how can I really reproduce that and do it like fast? Not to spend too much time, because obviously that's kind of painful, and also in some ways it's not about reproducing bugs, it's also about like, I want to write a test to show Ismael that this works, send that to him, he can run that in his computer, he finds a bug there, he can like reproduce exactly, sends the fix. And I mean, we want to have something that we can run the same thing again and again as a developer in local computer, maybe later transform that into a CI test and push that up. And I don't have a perfect solution for this. I think this is more a kind of, for today's meeting and brainstorm on that, I have a kind of proposal on how I have been suffering or trying to keep up myself. And maybe some other people in the team had found their own solutions, but I think at some point it would be nice to have a kind of a common approach to this. And one thing is, ideally, and this is different from the typical build release workflow, this is more like kind of developer workflow, is I prefer when CI can be run locally, because I can reproduce like when CI fails. If I have to go through log files, typically that means I spend too much time. And it's not about lazy, it's about being efficient in a way. So what I've been trying up to now, and it kind of works for me, but it's not like easy to use yet in a way that we can like just use it everywhere, but I think it's a starting point of discussion, and we can even use other things, is that I typically like to run things locally and later deploying to CI, the same thing. So what I've been using is MiniCube, that is just like setting up a local Kubernetes cluster, like without knowing much about it. I just like install MiniCube, and I have a local Kubernetes cluster in my computer with separate networking, with subnets, and we can even like apply IP tables there or do some fancy stuff like in the bridges between two pods or things like that. But that's kind of the fancy part. The easy part is just install MiniCube, and in the case of Mac, it just comes with Docker, so you don't even need to install that. Docker, typically I have a Docker for the KMS and a Docker for a Tendermint node that I can say, okay, I want like 3 Tendermint nodes, but they're all the same, so I don't care. I have one pre-installed Docker for the Tendermint node. And then with Golang Remote or with Visual Studio Code Remote, that I'm kind of a fan now, you can just like connect to a container that you want to use as the development container, and just work from inside the container from your host. So it's basically, later what I do is I have a Terraform script. Maybe it sounds complicated, but it's like quite fast. It's like install MiniCube, then prepare a couple of Docker files where you set up things that probably I should not need to do that, because we could have already a few Docker files ready for like the typical cases, like easy Tendermint node and an easy KMS system and blah, blah, blah. Then I say Terraform, I need like 3 nodes of this Docker and 3 nodes of that Docker and stuff like that. And I click deploy and I get my Kubernetes local network running in that situation. And with Visual Studio Code, I can SSH directly into a container I want to work in, and I can put breakpoints, I can do whatever I want. So I'm kind of like running my own network and working on one of those containers, or even maybe 2. I just SSH on any of those. And with Code Remote, you can have an IDE inside a container that is running on your host. So it's kind of like very convenient. Now, with Ansible, it's kind of fancy if you want to trigger failure on some of the nodes. But the problem with Ansible for configuration, or at least my experience, is that it runs the thing when you want to install them. And I don't like that, because when I want to start or stop the network, I just want to start from the same thing and we are waiting. And when you build a Docker container, that it's kind of pre-built. It's already configured in the way you want. And you can kill it, start it again, and it's again clean. While when using Ansible, you have to start a kind of rough, empty operating system and install everything every time. So I find that like for setting up for my typical development process, I find that kind of too slow. I prefer to say Terraform, get these 3 containers on from scratch, and I pre-build them like maybe at the beginning of the day, and that's it. I always have the same Tendermint node.
So now, I mean, we can address that issue with potentially by baking like AMIs, at least for Amazon. We can make an AMI with everything that we want installed, and then and then it's already on. Ansible doesn't have to worry about installing everything. But I think in any case, I mean, we do want some like really live networks, potentially using Terraform and Ansible for some of the longer term testing, but I think it's probably overkill for what we need for the KMS. And so for the KMS, I would expect that we can get most of what we need out of Docker, and that way we can also easily reproduce things locally on small networks running on your laptop, and also integrate it into the CI. So yeah. I think so really what we need to figure out is how to take, so we have this current, the like make localnet, makefile command, which just uses Docker Compose and the local Docker image to set up, test nets locally that you can use for some debugging and testing. So I think potentially that provides a baseline for starting to integrate into the CI and starting to test more things like the KMS. So I don't know if you've looked at that or.
So I mean, what I did is try to move the Gaia tutorial for 4 nodes into this configuration, which basically is what you are describing. The only thing is that in some way I have been playing mostly with Gaia using the latest Tendermint or things like that, rather than a pure Tendermint node. I don't know if that makes sense.
I think that's overkill.
Okay.
I think we can just do this testing between Tendermint and the KMS. We don't need to. I mean, there shouldn't be any application-specific logic or influence over the signing. So just using the dumbest, simplest application that comes with Tendermint, like the KV store, should be, or even the null app should be sufficient for testing. So I don't think we need to loop Gaia in. I mean, ideally, whatever we build would be very easy to reproduce on the Gaia side as well if people want that kind of extra assurance. But I don't think we need to start with that. But it sounds like the challenge is really about cross repo testing both ways for both, Tendermint integration test should include the KMS, and the KMS integration test should include Tendermint, and they both need to be able to specify which version of the other, or potentially which branch of the other they're working from, so that you can easily, run the test locally with your latest changes, and then, once things get tagged, they'll run in CI as well, or even before they're tagged or whatever.
Yep.
Yeah.
The only reason I said Gaia is because that's what I was using, but I completely agree. I mean, for kind of doing this, we don't need that.
Right.
So kind of that's kind of the take on testing. Now, I understand the thing, like what you said about AMIs and Ansible. The thing, Ansible, I have nothing against it. Like, I really like it, but it's more like kind of for maintaining a system that is like kind of online running, and you want to make a tiny change here and there. But here, I mean, Docker's, like the containers, we just want snapshots that are always the same. And we don't need to keep them kind of alive or changing the configuration here and there. We just want like 3 pure Tendermint nodes running right now, and one development container where I have like my, debug session.
Yeah, no, I agree. Ansible shouldn't really be relevant here. I think we want to just do all of this with Docker at the most.
Yeah, actually, I mean, this is something that we discussed, and actually you wrote too in GitHub some weeks ago. Why don't we test it with Docker, and that's it. Yeah.
I wrote that?
You wrote, why don't we use Docker Compose? Yeah.
Yeah, so question remains.
Yeah, exactly. Well, I mean, the only issue there, but it's not really much applicable here, is in the case of USB connections, Docker is not like too good. You need to use typically a virtual machine or something like that, because Docker sometimes gets a bit complicated when you want to test with real hardware. But this is something that we don't care too much, because what we are testing here is just the connection between the KMS and.
So as long as we can simulate the KMS failing, like as long as we can simulate the KMS talking to hardware, i.e., like imagine we have a test, like imagine signatory, I guess, or whatever. The KMS can wrap signatory in a way that it exposes a signing, like an in-process signer that randomly fails, to kind of simulate as if it were talking to a USB device that could also fail. And so that we make sure that kind of failing is somehow part of the integration story. But otherwise, again, I don't know that, I think we want to keep the integration testing focused on the actual integration point, and not confound it with too many variables like, oh, are you using different hardware, or are you using different applications, all of that. As long as we can like simulate, whatever differences might come up. Yeah. So
I mean,
the hardware piece should kind of be tested independently. And for that, totally Docker is probably going to get in the way. But that seems more on the signatory KMS testing side. Whereas with the integration piece, I think we can keep it relatively simple and focused on testing like that connection. Maybe we'll need some kind of randomized failure module within the KMS to really simulate everything we need. But otherwise, I think it should be possible to do this all within Docker relatively easily. Yeah. But so we have this KMS test harness. So I don't know. I haven't played with it too much. I don't really know too much about it. But is that something we can loop in or use here? I mean, ultimately, we want to. I don't know exactly. I mean, this is the like classic problem of having to test across 2 repos, and what leads all the big companies to use mono repos, which I don't think is really on the table for us. But maybe someone will challenge that position. So I don't know.
Well, I put that kind of here in the second. Sorry, in the second line, like integration testing, and having some kind of like top repo bringing all and running something nightly, or but I don't know. I mean, basically, I mean, to sum up, I think we have like two things: the PR, and now I'm happy to go into the details of the PR itself. In my opinion, it's quite simple. I mean, it's a lot of code, but I think it's clear. I think there is a kind of like bigger issue that is the testing. I'm happy to kind of, so the thing is to be efficient. I mean, I can do this myself, like starting this week and get it done and do some tests like this way or any other way. But probably, I mean, for this kind of planning session is an interesting topic to discuss, like in general, and probably also taking into account not only the KMS testing, but the developer workflow, and maybe also trying to address some of the issues that Anka was having with peer-to-peer and things like that. Because personally, something I found in Tendermint is sometimes I spend too much time setting up things, and when probably it could be something that we do it once and it works for everyone everywhere.
Yeah.
Just one question. You mentioned at one slide the setup where the KMS node is kind of in a data center and the nodes, Tendermint nodes, are in a cloud.
Yep.
Is this something which is like a common setup, or like do we assume any sort of setup when we talk about the deployment of KMS in terms of just, where is the KMS and where are the nodes? Like, are they sort of collocated, or they could be in theory a cross-wide area connection?
So this is something that depends on the validator, of course. But in most cases, the people I know, they have the nodes and the KMS in a data center where they have to pay for collocation, because they need to have a rack where they keep the ledger device or the UV or whatever kind of in their own rack. But in my opinion, like the nodes, in some cases, they could be running in a cloud provider, and maybe you don't need that in collocation, so it could be a lot cheaper. I mean, maybe with like, I don't know, a few U's or like a quarter rack or whatever, you could just like store the HSM and that would be all. But I know that there was also a discussion about like, but cloud providers are not safe and maybe they are like down. So I think that's why Tony was saying, okay, I would like to have like standby nodes where the KMS that is in my data center can like dial out and kind of trigger different nodes to get started or die. Does it make sense, or like kind of?
I'm just, I'm having more kind of general concern here when we develop these kind of systems. Because depending on what is the deployment setup, then it can be more complex or less complex.
Yeah.
It also affects the test scenario we want to set up, and so it's kind of challenging because we are not running the software, so it's third party deploying this, and they pick up how they want these boxes to work together. And so the question is, when we develop and we design them, what we assume? Like, do we assume as general setup as possible and then try to cover this with tests, or we sort of try to talk with the community and figure out what are the most common setups and then just develop for them and test them?
I can answer from what I understand is the case, but maybe Ethan or even Tony that is not in the call might tell the story in a different way, because I was not part of the initial discussion. But the typical case is the KMS and the node should run in different hosts, because you want them to, I mean, the security assumption was that the KMS dials out, so you cannot compromise the host where the KMS is. You can only compromise the host where the Tendermint node is, because obviously there is no choice there. You have a peer-to-peer network, so you have open ports anyway. But in the case of the KMS, you don't need any open port. It will always dial out. So the idea is you should put them in different hosts, physical independent servers. If that server is in the same rack or in a different rack, that depends on the validator. If that is in a collocated, like the Tendermint node is in a collocated rack or in a cloud provider, that also kind of depends on the validator. But the assumption is they are typically running in different computers, different independent physical servers. And the HSM is plugged to the server where the KMS is. So it would be too weird if someone is using something like a USB tunnel or something like that. Maybe, but typically it's plugged into the same device, like same physical server. And I know that some people pay for some monitoring system. So for example, I know if someone opens the door of the rack where the KMS is located, they shut down the KMS or they turn off the HSM or things like that. So they have some kind of like active security in the rack where the KMS is, which in the case of the Tendermint node, it doesn't matter.
Okay.
So, I mean, pulling it back to this testing question, ideally the kind of harness we set up that's part of our CI would be not too difficult to modify for kind of, you know, going back to Jarko's question on where do the responsibilities lie? Is it like on us to make sure that our integration tests are covering every possible scenario of how someone might use the KMS? Or, you know, should we focus on kind of the most common scenario, but ideally maybe we can have the test harness be such that it's not too difficult for people who want, you know, a more dynamic or esoteric setup to actually extend the harness to test their particular setup. You know, to see, you know, if a change somehow affects them or something like that. And maybe they can kind of suggest, hey, can you include this test as part of the integration test? It's a, you know, a small extension on the current harness or something like that. But in any case, the point is we need a proper harness that's like relatively easy to use, both in CI and manually, that kind of works with what we already have. And yeah. This
is something that probably Thing can confirm, because maybe I'm 90% sure, but maybe it's wrong. So
the thing is with the test harness is when we initially built the test harness, it was a sort of phase one, step one towards a better sort of set of integration tests between the KMS and Tendermint. And the test harness that currently exists in the Tendermint repository is designed to be used from the KMS's side. And so it doesn't actually test things from Tendermint's side, if that makes sense. It uses Tendermint's code to provide the Tendermint side of their interaction, but then you're supposed to actually run it from the KMS side. Now, there was still some question about, do we write a similar thing for Tendermint from the KMS side that we then pull and put that into the Tendermint CI pipeline. So we initially put this, because it was easier to modify this and quicker to modify this from the KMS's side, we initially put this test harness into the KMS's CI pipeline. But then again, without the strict checks from both sides, then quickly Tendermint will tend to diverge from what the KMS functionality is. So again, the question is like, how do we go about this testing strategy? Do we write two separate test harnesses? Do we write a single one that is in a separate repository that gets executed? So it's a bit messy and complex.
I personally see the test harness like, well, I don't have any drawing here, but very useful, and it's being used properly as unit testing because it provides a mock, like a kind of light implementation on the other side according to some specs that unfortunately we don't have the specs, but actually that's what it's doing. It's like kind of mocking and kind of providing something for unit testing. And we are actually using that. I think what I would like personally is a full node and a full KMS interacting between them, and maybe some kind of like monitoring thing that is checking that they do what they are supposed to do. I think it's not that the test harness is the problem. I think what we're missing is the real full integration test.
Yeah, but these kind of tests, at least in the microservice architecture, where you sort of also have separate components, these kind of integration tests tend to live in a separate repository. At least
yeah, exactly.
one. This again, like different team can choose different strategy, but like to the best of my knowledge, this is what was at some point considered as standard, and I used to in a previous company write integration tests like this. So then you configure, the versions, and you integrate this as part of your CI, but you don't write this code directly in one or the other repository, because then you need to essentially duplicate the same thing.
Yeah, and I completely agree, and I use also the same. So, I mean, what I put here is that we need some CI there to ensure compatibility, but we also need integration testing, like some kind of nightly or maybe for each PR is like too much. And we also need kind of a canary or like a testnet that is like running this for a long time. I think we need like these different levels. I completely agree that this,
it's part of this integration test or separate repositories that it works with the binaries essentially. So it should not touch the code directly. So when we talk about integration tests, they should really be like from, if you want, kind of user point of view. So essentially you build the version, you build a Docker image, which is official one kind of, and then you have integration tests, which are pulling different repository and then orchestrating tests there.
Correct.
Yes, these are effectively contract tests.
That's this way I've been working on, which is basically I get a predefined Tendermint, I don't know, version 1.2 and a KMS version 1.4, and I put them together and I check with something that they work together well, and I say, yeah, that's good.
So this is the plan. This is like so we have a plan to have a separate repository for integration tests, or?
I mean, as a plan, I don't know. I mean, this is for the planning session. Like we have to put all these together. But I hope I didn't like mess up too much with such a kind of broad presentation. But I'm not saying we need to do the integration testing in the CI of each PR, but we need integration testing. I think we have to layer this into I mean, I would say we have like 4 things. One is the typical developer life. Like, I think it would be good if we can run that locally and code and maybe prepare the integration test locally in a kind of easy way. The other is we need some CI, we need some integration test, and maybe some staging testnet. I mean, those are kind of the 4 things I would say would be good to have. And if they all work similarly with the same kind of infrastructure, it would be ideal, because then when there is a problem in integration, I can run the whole integration test locally. And that's why I like this idea of having like a Kubernetes or kind of Docker Compose, I don't care, local network where I can get the integration test that is failing and running here, because I think it is expensive and too much latency, and it's a pain to have a kind of AWS that we all have to share, and I have to call like Anka to say, oh, Anka, I need AWS access because I have this issue here.
No. We'll stick with Docker.
Yeah.
Yeah. So the main thing to figure out is like where it lives and how it pulls the things together. And the simplest thing is, sure, we could make another repo and it could refer to both, and maybe that's it could refer to both, and then they could respectively refer to it to actually as part of their CI. And maybe that's the best place to do it. So the iterations can move quickly. So it's just a test repo. From a higher level philosophical perspective, the fact that every time you have 2 repos that work together requires the creation of another repo to test them together is a sure sign that something is incomplete in the software development story around Git repos, but that's a problem for another day. So I guess we'll do that. Let's make another repo. I can make that after this call, and we can start focusing the full integration test story there. And I guess start with the developer focus so that we can make sure that we can test it locally in a reproducible way on our respective machines, and then whatever we kind of set up, then we can add that into make it run as automatically as possible so that we can then refer to it from CI pretty easily. And then we have at least those 2 points of like it running in CI and it running locally. And then, you know, we can think about adding it, making it actually run in kind of a long-term way. And I guess the other thing is, yeah, we don't necessarily want it to run on every pull request, right? That's what you were saying. So either we figure out some kind of nightly build strategy or a release-based strategy. I think if it only runs on release branches, that might be okay. Yeah, but I guess the main thing is to actually set it up in that repo so we can run it locally, and then we can figure out how to integrate it with the CI.
There was a discussion in Cosmos about something related in a way. I don't know what happened with that, but the idea was that I've seen that also in some Google projects where you can like have a kind of bot in GitHub where, for example, you say integrate test this, and that triggers the test and adds that to the PR kind of checks. Yeah. So in that way, that could also be a kind of fancy way. If there is a test that we feel, or like, sorry, a PR that we feel, this requires more testing, you can like trigger that. And
sure. That's great. I mean, I had thought about potentially structuring the CI to be based on what changed. So it's like, if any code changes in that preval directory or package, it would trigger, you know, these tests to run, and otherwise they wouldn't have to run or something like that. But a bot also sounds pretty cool. Okay, should we move on?
So I'm not sure I understand what's the conclusion of this. So from what Juan is saying, we still need to build quite a bit in this framework. I mean, are we going to use the local net and create this Docker? What's the conclusion? I'm not sure I understand.
So
because there's missing pieces right there. Forget about which repository we put the tests. There's a big missing piece for the actually being able to write these tests in an efficient way.
So there's the harness that Thane wrote, and then there's Docker Compose, and then there's like the perspective on the thing, right? And so right now the harness has been like, oh, this is phase 1. It lives in the KMS repo. I think what we're saying is now let's graduate it to the next phase where it's going to live more independently. It's going to continue to be built out so that it can be used both from the Tendermint repo and from the KMS repo, so that it sets up, you know, larger network using the kind of Docker Compose tooling that's already in Tendermint. You know, there's going to be a lot of like subtle decision points around that I don't know that we'll flesh out right now. Maybe that's for another presentation or something on how we actually set up this test harness. But I think that,
I mean, that test harness, if we talk about like Thane test harness, that means developing kind of the other side of the test harness.
Right.
But at the moment, I'm using Thane test harness. I mean, actually updated that so it runs in the PR. That's working. But I would still consider that kind of unit testing.
Right.
It's kind of an integration test, but like you said, it's a mock integration test. It's like it's actually what I intended to be was a contract test to make sure that using actual Tendermint code, because those are the libraries that I use in the test harness. Using actual Tendermint code to allow the KMS to talk to this mock Tendermint node, make sure that it does actually.
So it uses the Tendermint code, but not the Tendermint node.
No, so it uses now from I was checking Juan's PR. It uses now in his PR, it uses his code. There we go. The signer client, listener endpoint, and so on. It basically exposes that, and then it runs a couple of mock operations like signing a vote, and just to make sure that everything that those kinds of functions work. But then how do we then test things with, say we have from the Tendermint side in the CI pipeline, how do we then test that the KMS contract is met? And how do we keep track of this matrix of which versions of KMS are compatible with which versions of Tendermint? And that's the tricky bit. Right now, the code that I wrote was literally, like I said, the KMS, it's the contract test for the KMS. So the contract test, the signer harness, sits inside the Tendermint repo right now. Because it uses the Tendermint code. we can move it out into a separate repository, but then we would need the equivalent as well from the other side, the KMS harness for Tendermint itself. And those two harnesses need to be kept in sync. Perhaps it's easier to keep them in sync in a single separate repository. It would most likely be easier.
But I think the point is, I think we're at the point where we want to test them both with the full version of each other, instead of just mocking it out using the code, actually run Tendermint, actually run the KMS, right? Yeah.
So the reason why I wrote that initially was actually to be able to incorporate this contract test in the CI pipeline on every single PR, so it doesn't slow things down. So it would literally take like 2 seconds to run a test, and you could actually see, based on the exit code of the test harness, you'll be able to see exactly which particular feature is not compatible.
Amazing.
So that was the initial idea behind the test harness. But if you want to, so that's sort of one level of testing. This is one thing we were talking about, Juan and Anka and Greg and myself, and Ishmael as well. There are different levels of testing. And this is kind of like a contract test, but I think that in addition to a contract test, or maybe instead of a contract test, I'm not sure yet. We have to think about this a bit more. Having a full integration test would definitely make sense. We just have to, I think, have a bit of a planning session around that to structure it.
Okay, so maybe we'll do a more focused call for the folks that are going to be involved in that to actually sketch that. Yeah, cool.
I think the only thing I can add there, but I mean it depends on, maybe we discuss that in the next session, is I can maybe prepare like a kind of proof of concept of this that I have been actually using myself.
Can we? I have serious hesitations with adopting Kubernetes as like a significant part of any of our automation right now. So to the extent that we can minimize the like if we can just use Docker and Docker Compose, I feel like that might be preferable. I don't know if everyone here is bought into Kubernetes. I've certainly never used it.
I only used it once, basically a more sophisticated version of Docker Compose.
That's what I understand, yeah. I read this hilarious article.
Not too bad, though.
What's that?
It's not too bad, though. It's like, I enjoyed working with it, actually. But it's a while ago.
Yeah, obviously, to reduce complexity, we can just use like Docker Compose and that's it. I mean, I think the only issue...
Totally fine.
But if you could actually show us just using Docker and Docker Compose and how you use Terraform, and then I understand we don't use Ansible, but I don't understand how we would simulate failures like the one you described, link down, which is also interesting for me in for the case, and then from your manual test we can figure out how we do this. End up with an easy way to write integration tests and automate things.
Yeah, I mean, if everyone is happy with that, I can prepare like a simple Docker Compose with no Kubernetes or Terraform, just Docker Compose thing. Yeah, I think the only experience I had with Docker Compose problems is that networking is different in Linux and Mac. I don't know if they fixed that, but there was a point where with Linux they were all bridged, but in Mac they were not, or something like that. The networking was slightly different, so it gives a different experience when you code with that. But yeah, actually Docker Compose is much easier, and I have used it more than Kubernetes. So
we have this like make localnet stuff set up in the Tendermint repo that uses Docker Compose, and I'm pretty sure it works the same way on both.
Cool.
Linux and Mac.
But it would be very interesting if we could extend the localnet to be able to introduce different versions, custom images, local repo images, all that. So that's
I can do it kind of like, if you're happy, I can do like a hands-on 30 minutes thing with a few examples.
Yeah, and all the I don't know how we can. Instead, I mean, localnet right now just creates 4 nodes, right?
No, you can configure it, right? Can't you?
I never look.
Or you have to add more to the. You have to add more.
The idea is to have the flexibility to create a certain network with and set up topology, image versions, and all that. And
so it's possible that maybe at that point it is going to be the case that we'll want some of the power of Kubernetes rather, because ultimately we're going to end up writing our own like Docker compose higher level thing, right? So
I mean, the only difference with Kubernetes Terraform is that you can like add or remove nodes in a kind of like easy way.
What does Terraform have to do with this?
So Terraform allows you to define like how the nodes in Kubernetes will look like. So you say, I want these
locally, even if I want to run them all locally?
Yeah, because you can separate them in different subnets, or I mean, it also defines the network. So you can say I want these two in a pod, and I want those two there, and I want this Docker and that Docker. Terraform is doing the compose part of Docker in a way.
I see.
So MiniCube Kubernetes is we don't use it. The only reason Kubernetes is there is because Terraform. So let's say we replace Docker Compose with Docker Terraform in a way. The Compose part is the Terraform configuration, and the MiniCube is like we don't even care. It's just like an installer that you need to put there, and that's it. But obviously we can use Docker Compose, and that's all right too.
Okay. So I guess we need to look into this a little more clearly, maybe with a smaller focused group. I think we should move on for now, though. Yeah.
Yep.
Cool. I'm gonna stop the recording.